Hello viewers, welcome back to my channel Experience Physics, and in this video lecture let us talk about the topic Kirchhoff's laws. Kirchhoff's laws, a pair of laws which are highly important to deal electrical engineering. Actually there are two laws we are going to see, right? Let me write them. Kirchhoff's current law and Kirchhoff's voltage law. In short, we will say this is KCL, Kirchhoff's current law, and this is KVL. This is also known as Junction rule. Junction rule. This is also known as loop rule. Okay. So we will see them. What is junction, what is loop, and how these laws are applied here to solve electrical engineering problems. Right. So first, let me say the statements. What Kirchhoff's current law states, right? Statement of Kirchhoff's current law is the algebraic sum of currents meeting at a junction is 0. The algebraic sum of currents meeting at a junction is 0. Right. Let me have one example. This is one junction. There are 4 or 5 wires. They are meeting at the junction. This is junction or node. Junction or node. This point. Right. Say this is one current, another current, and this will be another current, another current. Let it be I1, I2, I3, I4 and I5, right? I1 and I2 and I3, they are moving towards the junction. The arrow are important when you apply Kirchhoff's current law. I4 and I5, I4 and I5 are moving away from the junction, right? So the algebraic, the word means with signs, with signs. So we have to take the signs. So signs are indicated through the arrowheads, right? So this is plus and this is plus and this is plus and this is minus and this is minus. Plus I1, plus I2, plus I3, minus I4 moving away, minus I5 is equal to 0. Or we can write I1 plus I2 plus I3 is equal to I4 plus I5. So using this expression, I can rewrite the statement as the sum of incoming currents is equal to sum of outgoing currents. Sum of incoming currents is exactly equal to sum of outgoing currents. Sum of incoming currents is equal to sum of outgoing currents. This way, we will rewrite it. Sum of incoming current, I means incoming, is equal to sum of outgoing currents. In short, Kirchhoff's current law can be said as sum of incoming currents is equal to sum of outgoing currents. So this is junction. This law is applicable at any junction, right? That is why it is called as, otherwise called as junction rule, right? So the point is the current will not stay here. That is the meaning. I1 comes, I2 comes, I3 comes. No current or no electron or no charge will stay at the junction, right? All the currents, all the charges, all the electrons, they are coming. Whatever the number of electrons they are coming towards the node or junction, they will leave through the another wire. So that is the point, right? So this is otherwise known as, this law is based on conservation of charge based on this. Kirchhoff's current law is based on conservation of charge. No charge is wasted at anywhere. No charges, no electron is wasted. Whatever the number of electrons coming through one particular wire, they have to leave through the another wire, right? So no charges wasted here or stayed here. So that is the meaning. Let's see Kirchhoff's voltage law. Next, Kirchhoff's voltage law. Let me first say about the statement. Again, the algebraic sum of potential differences. In Kirchhoff's current law, the algebraic sum of currents, but here potential differences. Around a closed loop. In Kirchhoff's current law, meeting at a junction, but here around a closed loop. Around a closed loop or path is 0. So the algebraic sum of, again algebraic sum. So with plus or minus, with the signs we have to make the equations, right? So algebraic sum of potential differences around a closed loop is 0, right? Let me take one circuit, simple circuit. So here there are 3 components, one battery, 2 resistors, R1, R2, one battery. 3 components are here. So this battery has one voltage, one potential difference. This resistance, when some current is flowing through the resistance, it will also have some voltage or potential difference. This will also have another potential difference. If we add all the potential differences across or around the path, we will get the sum as 0, right? So I will elaborate it. I will take the circuit, or I will draw the circuit here. Say this is 10 voltage. This may be 3 ohms and this may be 2 ohms. So easily we can find out the amount of current which is flowing through this circuit. These 2 resistors are in series. 3 plus 2 is equal to 5 ohms. So 10 divided by 5 is equal to 10 divided by 3 plus 2. This is 2 amperes. So 2 ampere current is flowing through the circuit. 2 amperes, right? So solving Kirchhoff's voltage law, sometimes it's a bit difficult, not difficult, it may lead to give a wrong answer. If you do not choose the polarities correct, polarities means the signs, the sign minus plus. If you do not choose the signs correctly, it may lead to a wrong result, right? So I will recommend one way of solving such problems, right? Very simple method, easy method. I won't recommend this method, potential drops, potential gains. I won't recommend this method, right? So here potential is gained, here it is dropped, plus to minus, minus to plus, right? When it goes from minus to plus, it is potential rise. When it goes to plus to minus, it is potential fall or loss. No. Current entering terminal plus, mark it as plus. Current leaving terminal minus. The current 2 ampere current enters the resistors at this path, at this place. Make it as plus. Then obviously it is minus. Then the second resistor, it enters here. It's here. Then apply Ohm's law here. I into R. 2 into 3 is equal to 6 volts. Between plus and minus 6 volts, you write 6 volts. Between plus and minus, you write 2 into 2 is equal to 4 voltage. Then apply Kirchhoff's voltage law. 1, 2, 3. 3 components are here. So 3 terms you must write. Count the number of components. Accordingly, you must write the number of terms. The right hand side, you can write 0. That is why, that is how Kirchhoff's voltage law is satisfied, right? 4 corners I am seeing. From any one corner, you choose any one corner. From the corner, you walk towards the path. You just walk. Assume a person, he is walking along the path, right? Let me start from this corner. From this corner. See the sign, write the value. Enough. I won't recommend this method. See the sign, write the value. 100% you will get correct result. 100% you will get correct result. I am seeing first minus sign. I am walking along the entire route, entire path, entire loop. From here I start. I have to come back to this point, right? I am starting from this point. I am moving. I am seeing the minus sign. Minus, what is the value? 10. Then I come here. I am seeing plus sign. First I see plus. First. Before entering the component, this is one component, this is another component, this is the third component. Before entering the component, what is the sign you are seeing? Plus sign I am seeing. You write plus 6. Then I am seeing plus. Third component I am entering. I am seeing plus. Right hand side 0, it is must. Then only Kirchhoff's voltage law is satisfied. Minus 10 plus 6 plus 4 tallied. 6 plus 4 is equal to 10. This is how Kirchhoff's voltage law is easily written to solve, not to confuse the polarity markings and polarity usage. See the sign and write the value, right? Let us go to solve some problems. You will get you will understand this method. You will know this method is very, very easy to you to apply, right? One more point. So actually battery is an energy source, right? So 10 voltage is equal to 10 voltage. This is 10, this is 6, this is 4. This 10 voltage is distributed here, right? So this energy is distributed. That means this law is based on conservation of energy. So Kirchhoff's current law is based on conservation of charge. Kirchhoff's voltage law is based on conservation of energy, right? Yes, let us take some examples. Kirchhoff's junction law follows from the conservation of charge. Yes, right. Kirchhoff's loop law follows from the conservation of energy. Yes. Both 1 and 2 are correct. Next. The electric resistance of an open circuit is open circuit. Yes. Yes, 10 voltage, assume. This is one open circuit. No current flows, right? Electric resistance, that means assume if there exists some resistance, its value must be very, very high. Its value must be very, very high, because resistance has a property to oppose the current, right? Unless otherwise it has very, very high value, it won't allow any current through it. That is called open circuit. You know, through the open circuit current is zero. Open circuit, through open circuit current is zero. If R is equal to infinity, then I is equal to V by R is equal to V by infinity is equal to 0, right? Open circuit current is 0. If R is replaced by infinity, current is 0, right? So infinity is the answer. The electric resistance of an open circuit is infinity. The opposite way, for example, if I make a short circuit, this is open circuit, this is open circuit. If you make it as a short circuit, the current is infinity, because now R is equal to 0. In a short circuit, the R value is 0, very, very minimum. So I is equal to V by R is equal to V by 0 is equal to infinity. Infinity means very, very high amperes that will flow through the short circuit, right? Infinity ampere means very, very high. What is the maximum possible amount of current this battery can deliver, right? If it is 10 voltage battery, it will have some value. If it is 100 voltage battery, it will have a higher value than this 10 voltage, right? Infinity is not a fixed number, right? The highest value of the current that can be flown through this battery, right? That's all. Right, another point I can tell you, I have an R value, say 2 ohms, this is 4 voltage. So the current is 4 divided by 2 is equal to 2 amperes. Current through this 2 ohm resistor is 2 amperes, V by R. If I make a short circuit using another wire, I take another wire and I tie the two ends of the wire across the resistor. This is one short circuit. Then what is the value of current flowing through these 2 ohms? No current will flow through these 2 ohms. Now it is not 2 amperes, because it is the infinity amperes. All the current will be flowing through the short circuit only. The maximum value of I max will flow through the short circuit, right? For example, let me have another circuit. This is another 2 ohms, right? So before I connect a short circuit, 1 ampere current. Now it is 2 ampere current. It is bypassed. So short circuit means a bypass. A short circuit means all the current will be flowing through the short circuit only. So through this resistor, I is equal to 0. No current will flow through the 2 ohm resistor, because the tendency of electrons is they will by flowing through any circuit, but they will like to enter the negative terminal of the battery as soon as possible. The electrons, if you assume all the electrons are coming from the positive terminal, that is the current is coming, conventional current, if it is coming, so it will like to take this route only. It wants to reach the negative terminal quickly, very fast, right? So they want to take this route, right? So short circuit means it is a bypass, right? The resistance of an ideal voltmeter is used to measure voltages between 2 points. Ideal voltmeter means it is practically there will be some resistance. Ideal voltmeter have infinity resistance, right? Yes. This is some V, this is some R. This voltmeter is used to measure. This voltmeter is used to measure the voltage across this R. Let us have another resistance here. This is R2, R1. I connect a voltmeter across R2 between these 2 points. So this voltmeter will have the reading of the voltage across this R2. So it's an open circuit. Voltmeter is a open circuit. Voltmeter is an open circuit. Open circuit means resistance is infinity. The opposite action, ammeter, right? Ammeters are used to measure the currents. Ammeter is a short circuit. Ammeter is a short circuit. Ammeter is a short circuit. In any circuit, if you find any ammeter is connected, you can replace it as a short circuit. Nothing wrong. If you see one voltmeter, you can replace it with a open circuit. Nothing wrong. Yes. In the figure shown below, the reading of the ideal ammeter is. Yes. Just now I have told you, there is an ammeter. You can replace the ammeter using a short circuit. Nothing wrong. In the figure shown below, the reading of the ammeter means current through this 40 ohm resistor is asked. The question is nothing but what is the value of current flowing through this 40 ohms? So this is I2 and say this is I1, say this is I total current. So from 28 voltage battery, I is coming, it is divided into 2 currents at this junction I1 and I2. The question is what is the value of I2? So Kirchhoff's voltage law can be written simplification of networks. It's another way of solving this problem that will lead us to get the quick result, right? See, if you trace the circuit, you want to find the value of current through these 40 ohms. That means we need voltage across these 40 ohms. If I find the voltage across these 40 ohms, this V divided by 40 ohms, Ohm's law, V divided by R will be the current through that particular resistance. Across the particular resistance, what is the voltage available? Through the resistor, what is the current? That means across the terminals, find the voltage divided by its R value, you will get it, right? So our job is first, the step 1 is first to find the voltage across these 40 ohms. So voltage across these 40 ohms, the same voltage will also be available here. across these 20 ohms also, right? These two can be compressed. These two are parallel. Different current means they are parallel. Same current means they are series, right? I1, I2, then through this I1 plus I2. I is divided as I1 and I2, and I2 here comes, I1 comes, both are joined here, then I1 plus I2, which is nothing but I. The same I is flowing through 8 ohms also. So I is flowing through 20 by 3, I is flowing through 20 by 20. So these two are in series. Different currents, parallel, same current, series, right? So we can redraw the circuit this way. This is the combination of 20 and 40. This is combination of 8 and 20 by 3. So 20 by 3 plus 8. The two resistors are in series. I am finding the equivalent resistance. So 3 into 8, 24. 20 plus 24 by 3 is equal to 44 by 3. So this is 44 by 3. And this combination, these two are in parallel. So 20 into 40, two resistors in parallel, divided by 20 plus 40. So this will be 800 divided by 60. This will be 40 by 3. So this is 44 by 3 and this is 40 by 3. 20 and 40, when you compress them, parallel combination, 40 by 3, 20 by 3 plus 8, 44 by 3. Right? So this is the total current from the battery, I. So this is the total current, I. Fine. So I into 40 by 3 will give the potential between these 2 points, say X and Y. X and Y. Between X and Y, this is Y and this is X. Between X and Y, I into 40 by 3 will be the potential, Vxy, or I can write. So this is Vxy. This Vxy we need. Once Vxy is found, this Vxy divided by 40 will be the answer. That is the current flowing through the ammeter, right? So Vxy I am finding. These two are in series because same current is flowing. If same current is flowing through any number of resistors, they can be added, series combination. I again I. So 40 by 3, this is 44 by 3. So the sum is 84 by 3. This will be 28 battery, I. So we need the voltage. So first I find I is equal to 28 divided by 84 by 3. V divided by R, right? Which is equal to 28 into 3 will be 84 divided by 84, right? 28 into 3 divided by 84, which is 84 by 84, 1. So the current is 1 ampere. 1 ampere is the current which is flowing through the battery. 1 ampere, 1 ampere, right? From the battery, 1 ampere current comes. It is divided into I1 and I2. Then it is joined as 1 ampere. It is returning back to its battery 1 amperes, right? So how much portion of this 1 ampere is divided? What is the value of I1? That is not in the question. What is the value of I2? That is in the question. This is nothing but the current through this ammeter, right? So this voltage, 1 ampere it is coming. A portion of 1 ampere is divided as I2, But this Vxy we can find 1 ampere into 40 by 3, right? This combination is 40 by 3 between x and y. Between x and y, this combination gives me 40 by 3, the parallel combination. So this now it is found 1 amperes. This 1 amperes into 40 by 3 will be Vxy, right? So Vxy is equal to I into R, 1 ampere into 40 by 3. So Vxy is 40 by 3. Now it is found. Then I want I2. I2 is equal to Vxy divided by 40 ohms. Straight away let me write 40. So Vxy is 40 by 3 divided by the resistance value. So 40 and 40 will be cancelled. The answer is I2 is equal to 1 by 3 amperes. So the current through ammeter is 1 by 3 amperes. Answer 1 by 3, right? So I am compressing it, I am merging it series, and these are parallel. I am making as a single resistor. So when single resistor is found, 1, 2, 3, 4 resistors are compressed and a single resistor is found. Single resistor found means the total current from the battery is found. The total current from the battery is found, then that value and the compressed value will give Vxy. From Vxy divide the 40 ohm resistor, then find what is I2 over. What is the current I in the circuit as shown in figure? What is the current I? 2 ohms, 2 ohms, 2 ohms. These are in series, right? I. So finding series, what are the resistance which are in series and what is the resistance which is coming as parallel is not a difficult thing. Most students are confusing themselves in this point, right? I is divided as I1 and I2, right? It sees the I finds one junction here. Whenever it finds a junction, it is divided into two currents, I1 and I2. I2 is flowing here, I2 is flowing here, I2 is flowing here. So all the three are series. But I1 is a different current, right? So I1 through R1, I1 is flowing. So it will come as a parallel. 3 voltage and this will be 2 ohms and this 3 are in series. 2 plus 2 plus 2, 6 ohms. 3 voltage. I is the current which is in the question. Now this is I1 and this is I2. I1 and I2 I am writing for our convenience, right? It is not in the question, but two different currents. To give the meaning of they are in parallel, I am writing I1 and I2, right? So two different currents are flowing. That means 2 and 6 are in parallel. This is 3 voltage, 2 and 6. 2 into 6 plus 2 plus 6. Parallel combination, the equivalent value R1, R2 divided by R1 plus R2, right? So this is 12 by 8. So this will be 3 by 2. 3 4s are 12, 2 4s are 8. 3 by 2 ohms. Then the question is the total current which is coming from the battery. From the battery, not I1 and I2. I1 and I2 I wrote it for our convenience. To find which are the resistors they are coming in series and which are the resistors which are coming in parallel. To find them, I am writing I1 and I2. So through the battery, the question is, what is the value of current? I is equal to V by R. I is equal to V by R. V is equal to 3 voltage. R value is 3 by 2. 3 by 2, yes. So this will be 6 by 3. The answer is 2 amperes. 6 by 3. Yes, 2 ampere is the current. Clear. Next problem. Two cells of EMFs, 4 voltage and 8 voltage, connected to two resistors 4 ohms and 6 ohms as shown. If 8 voltage is short circuited, this is short circuited. If 8 voltage is short circuited, then current through the 4 ohms. What is the current now? Already I have told. So the current, if it finds a bypass, this is bypass. Short circuit is a bypass. All the electrons, they are coming here. The value of current, all the electrons, they are coming here. They see a bypass. They will take their route through this bypass only. No current will flow through the resistor. Whatever value of resistor you connect across a short circuit, it will take the route of short circuit only, right? So the equivalent circuit, after it is short circuited, this is 4 ohms and this is the short circuit. The 6 ohm is available physically, but it becomes ineffective. The 6 ohms will become ineffective. It becomes ineffective. When a short circuit is made across any resistor, here it is 6 ohms, the 6 ohms will become ineffective. No current will take its path. All the currents will be taking the short circuit only. This is 4 voltage and this is 4 ohms. I is equal to V by R 1 ampere. V by R 1 ampere. 1 ampere is the result. Yes. The potential difference across point B and C. Points B and C in the given circuit is very interesting problem, right? The answer is 10 voltage. The same 10 voltage is available across B and C. VBC is equal to 10 voltage. VAB is also 10 voltage. Just by seeing the circuit diagram, we can write. No need of making any calculations, right? The B is connected to the negative terminal. The C, through the short circuit, it connected to the positive terminal. I can write B here. I can also write CEDA here. CEDB. All the points are not B. EDA. All the points are along the short circuit. All the points are kept at same potential along the short circuit. If any resistor comes here, that is a different case. But here no component is there, only short circuit, right? So all the points are kept at same potential, right? So C is connected through the short circuit to the positive terminal. C and positive terminals are joined. B and negative terminals are joined. So the voltage across VB is 10 voltage. B and C, right? Voltage across B and C is 10 voltage. A and B also 10 voltage. So this terminal is plus and this terminal is minus. But here this is minus and this is plus. So polarity is not important here. The magnitude is asked. So between B and C, 10 voltage. Just by seeing the circuit diagram, we can write the answer. The current in the 5 ohm resistor will be bypass. So all the current through the batteries will be circulating through the bypass only. I is equal to 0. Through 5 ohm, 0. Answer is 0. The potential difference VA minus VB between the points A and B in the given figure is. Potential difference is asked. So we can use Kirchhoff's voltage law. If potential difference between 2 points is asked, we can easily find it using Kirchhoff's voltage law. But the statement of Kirchhoff's voltage law is the algebraic sum of potential difference around a loop is 0. Where is the loop here? There is no loop. There is no loop here. This is an open path. It is not a closed path. We can solve the problem by using one unique way of solving this. I am going to use it. I am going to tell you dummy battery concept. Dummy battery concept. Yes. This is a unique way of solving this kind of problems, right? If we connect a dummy battery across the unknown potential, we can easily find it, right? 100% you will get the correct answer. The question is VAB, that is VA minus VB means it is VAB. The question is to find VAB, right? But we are seeing one open path. No loop is found, right? So I am going to connect a dummy battery and I will complete the loop. This is the dummy battery. I assume or I imagine a battery is there. VAB is asked. So I give the positive terminal to A. That is another important point. A is coming first, so make plus here, VAB. Now through this dummy battery, we are finding a closed loop, right? 4 corners I am seeing. 4 corners, 1, 2, 3, 4. From any one corner, you start applying Kirchhoff's voltage law, right? What I have told you already. No potential rise or fall or potential gain or potential drop. That concepts are not at all required here, right? I won't recommend here, right? Just see the sign and write the result. This is the plus terminal. Assume the current is flowing this way. 2 ampere already it is given, right? No need. 2 ampere current is already it is given. So current entering terminal plus, don't forget it, entering terminal plus, leaving terminal minus. I into R, Ohm's law. V is equal to I into R, 2 into 2, 4 voltage. The voltage across the 2 ohms. Then 3 voltage. Then current enters here. It's a series circuit. Through the dummy circuit, we have closed the loop, right? Minus 2 ampere into 1 ohms is 2 voltage. Then we will close the loop. From this point, I start to walk. I walk around the loop from this point. First I am coming here. Then only for the components you write the terms. 1, 2, 3, dummy battery also. 1, 2, 3, 4. 4 components are here. So 4 terms must come in your equation. Don't forget. Count the components and write the terms, right? 1, 2, 3, 4 components I must have, plus 4 voltage. First I see plus terminal, entering terminal plus, the value is 4. Then I see plus, longer line, 3 voltage. Then I see plus, 2 voltage. Then I come to here, I am walking, I see minus here. First I see minus. What is the polarity? First I am seeing minus here, minus VAB. The value is unknown. I make it as unknown value VAB is equal to 0. So 4 plus 3 plus 2, 9 minus VAB is equal to 0. VAB is equal to 9 voltage. The answer is 9 voltage plus 9. Yes. Mark the polarity, that are signs. Entering terminal plus, leaving terminal minus. See the sign blankly, blindly see the sign and write the result. Don't think whether it is plus 2 minus or minus 2 plus, whether it is potential gain or potential drop. Don't think too much. Just see the sign and you write it, right? For the unknown terminal, unknown voltage, you connect your one dummy battery and make it as a loop. There is no loop here, and you form a loop artificially, right? That's all. What is this problem? In the circuit shown, the value of R in ohms that will result in no current through 30 voltage battery. R is not given, R is to be found. The R value must be such that it will make the current through 30 voltage battery 0. So there is one current which is flowing through this 30 voltage, or it is chosen such that this current should be 0. Say this is I1, from the positive terminal, I assume I1 is flowing. From the positive terminal of the second battery, I assume I2 is flowing. So two loops I am seeing. This is one loop, A, B, C, D. Then another loop, E, F. There are two loops. For loop A, B, C, D, let us write the Kirchhoff's voltage law. Right. Again I start from one corner. From this corner, from A, I start to walk around the path. This is a closed path. I see minus sign here, minus 30. First I see minus, the value is 30. Then I come here. But before completing this path, let us mark the polarity, because these are in resistors value, ohms, we have to find the voltage value. I2 goes entering terminal, leaving terminal, right? Then it is returning this 20 ohms plus, yes, minus. This will be I into R, plus minus I into R, I2 into R. No, I1 plus I2 into R. This current is I1 plus I2. So this voltage is I1 plus I2 into R. The value of current which is flowing through R ohm is both the currents, I1 plus I2, R, Ohm's law, I into R, right? Then this is I2 only. Through this branch, I2 is flowing, right? This is I1 plus I2. Then I2 is divided here, I1 is coming here, right? They are separated. 20 into I2, I into R. R value is 20 ohms, I value is I2. Then this is current entering terminal. Through this 10 ohms, current enters this point and leaves this point, right? 10 into I1. Over. For all the components, we have written voltage value. 10 I1 is voltage value, 10 is resistance value, 10 I1 is voltage value, 20 is resistance value, 20 I2 is voltage value. Similarly, I1 plus I2 into R voltage value. Now all the components are having voltage values. Now we can easily write the Kirchhoff's voltage law. As I told you earlier, I will start from this point, from this corner A. First I see minus 30. Then A, B, C, D. This is the loop I want to close. Then I am coming to the second component. This is 50 voltage battery. First I see the positive terminal. I am writing plus 50. Then I see minus terminal. Through this resistor I have to cross minus, the voltage value is 20 I2. Then I see plus terminal. Look at it. The value is 10 I1. Yes. Kirchhoff's voltage law is written. The condition is that will result in no current through 30 voltage. So the condition they are asking to make I1 is equal to 0, that is the condition, right? I1 is equal to 0. I1 is equal to 0, so 10 into I1 will become 0, right? So this is 50 minus 30, 20. 20 is equal to 20 I2. So I2 is equal to 1 ampere. So for the first loop, we have found I2 will be equal to 1 ampere if we make I1 is equal to 0. Next, the second loop, CEFD. Second loop, CEFD. From any one corner you can start. 4 corners, from any one corner you can start. From C I am starting. From C I am starting to walk around the path. From C, first I reach the R value, R. So the voltage value is I1 plus I2 R. What is the polarity? Plus sign. Plus I1 into I1 plus I2 into R. Then this component, 20 I2. Yes, this loop I am considering. So I have to cross this 20 ohms plus 20 I2. First I see plus terminal plus 20 I2. Then I see minus sign here. I entered through the minus sign. I entered minus sign through the minus sign. Minus 50 is equal to 0. 1, 2, 3. 3 components. 1, 2, 3. 3 terms, right? The condition is I1 is equal to 0. So this will be 0. So this is I2R plus 20 I2 is equal to 50. I2 is already found, equation 1. From equation 1, I2 is 1 ampere. So R plus, this is R plus 20 I2, I can rewrite it as R plus 20 I2 is equal to 50. I2 is equal to, now let us replace I2 with 1. So R plus 20 is equal to 50. So R is equal to 50 minus 20, 30. R value is 30 ohms. Yes. I apply Kirchhoff's voltage law, then I use the condition. I am making I1 is equal to 0. I assume I1 is flowing through the battery, 30 voltage battery. Yes. So if you put 30 ohms resistor here, there won't be any current. Next problem. The given 4-terminal network is part of larger circuit. Yes, it's a part of larger circuit. Only a portion of it is given. The points A, B and C are at same potential. A, B and C. The potential difference between any one of the A, B, C and D is 40 voltage. This is 40 voltage. This is given. Then potential difference between A and O is, what is VAO is how much? The first point is, it's a larger circuit, part of larger circuit. The points A, B, C are at same potential. That means this is a short circuit. A, B and C. We can easily make it as a short circuit, right? It's a short circuit. A, B, C are now at same potential. You can collect any number of points on a short circuit, the potential will be same. So this is one condition. A and D is 40 voltage. Then what is A and O? Between these two terminals, what is the value of the voltage? So short circuit means, if you redraw it, you can simplify this network. Right? This is O, A, then this is B, then this is C. This is a short circuit we have made using the blue color. Using the blue color, this is a short circuit I made. A, B, C, A, B, C. This is O. But in O and D, another R is available. But A and D 40 voltage. 40 voltage. Yes. I assume a battery here, its value is 40 voltage. Then the question is, what is the value of voltage between A and O? So R, all the three are in parallel. This is A or B or C. I will write A only. A, B, C are made as a single point using this blue line, made as a single point. This is R by 3. R. 3 equal values are available. Parallel combination R by 3 is the result, right? R equivalent is equal to, you can find this way. 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by R. Then R equivalent is equal to R by 3. R by 3 I have written here. Then this is R. Between A and D 40 voltage. This 40 voltage. Then there flows some current. This is R by 3 and this is R. If you find the current, then that current and this R by 3 multiplication will give you the voltage across this AO, right? Let us find next the value of current that is flowing through the series combination. R by 3 plus R is equal to 4R by 3. 4R by 3. This is A and this is D. A and D. R by 3 plus R. 4R by 3. Then this is 40. This current is I is equal to V by R. 40 divided by R value is 4R by 3. 4 and 4. This is 10 into, it is 10. 10 into 3 by R. This I value is 10 into 3 by R. I is equal to 30 by R. So this current is 30 by R ampere. Then this current into this resistance will give you the voltage between these 2 points. I into R, Ohm's law, locally I am applying, right? So voltage across VAO is equal to 30 by R, I value into R by 3. Or then 3, 10 voltage. 10 voltage is the answer. VAO. Voltage between A and O, 10 voltage. 10 voltage is the answer. Yes. In the circuit shown in figure, the total current supplied by the battery. If you rewrite it, easily you can solve it. It is in a circular form of one circuit. You just rewrite it. Shift A here. Then these 3 ohms will come here. Then these 3 ohms. This way you can rewrite it. Right? A and C, between A and C, 30 voltage or 6 voltage is given. Then A and O, 3 ohm is given. Then O and C, this is C short circuit, 4 ohm is given. Then O and B, 6 ohms is given. A and B, a short circuit. This is the short circuit. A and B. Then B and C, 3 ohm is given. Check all the components are rewritten here. 3, 4, 6, 3. 3, 4, 6, 3. AC, OB. AC, OB. 6 voltage. Right. The 6 ohms and 3 ohms are in parallel. Right. Six and 3. Let it be A. This is, let me have a space here. Yes. This is O and this is A. This is 4 ohms. This is C. 6 and 3. The parallel combination will give me 18 by 9, 2. A and B, they are short circuit. So 6 and 3 are, the parallel combination is simplified. Then between B and C, the 3 ohms, B and C, this is not, this is O. Actually, this 3 ohm is connected at B. B and C, this is C. B and C, 3 ohms is connected, not here. This is O. 3 ohm is connected between B and C, right? So this is correct. B and C, 3 ohms. B and C is 3 ohms. These 2 and 4 are in series. Two and 4, it is 6 ohms. This is A, comma B. Then from here I can draw 3 ohms. Because B and A are short circuited. Now this circuit will become 6 and 3 are in parallel. 3 into 6 divided by 3 plus 6. 18 by 9 is equal to 2. 2 ohms. This battery is 6 voltage. The question is total current supplied by the battery. From the battery, how much current it is coming? Ohm's law, V by R. So I is equal to 6 divided by 2 is equal to 3 amperes. 3 ampere is the result. Option C. Yes. If you just redraw the given circuit, you can easily solve this problem. So any shape, if you find the given circuit is given in any shape, make it as a square form or rectangular form, right? The appearance wise, it will give us the easy way of attempting it. The potential drop across the 6 ohms. What is the voltage here across 6 ohms? Right, Kirchhoff's voltage law. Let us apply Kirchhoff's voltage law. Right. I assume a current which is 12 voltage from the 12 voltage battery. I assume a current here. This is only one loop, only one current. I. Current entering terminal plus, leaving terminal minus. Entering terminal through 6 ohms, entering terminal plus, leaving terminal minus. Right. From any one point, let us start writing Kirchhoff's voltage law from this corner. Let me write it. Plus 4I, this is 4I. I is the current I am assuming. 4 into I, this is 6 into I. Right. 4I plus 7. First I am seeing 7 here, plus 7. Then I am seeing plus here, plus 6I. Then I am seeing minus here, minus 12 is equal to 0. Then this will be 10I minus 5 is equal to 0. 10I is equal to 5. I is equal to 5 by 10. This is 1 by 2 amperes. The current is 1 by 2 amperes. Voltage across 6 ohm is in question. 6I. Voltage across 6 ohm is equal to I into R. I is 1 by 2. This is 6 ohms. 3 voltage. 6 ohms into half amperes, 0.5 amperes. So 3 voltage. 3 voltage is the answer. If the reading of ammeter A2 is 3.6 amperes, if you find an ammeter, you can make a short circuit. Nothing wrong. Ammeters are short circuit. Voltmeters are open circuit. Right. So current through this path is 3.6 amperes. That is the meaning of this line. Reading of A2 means current through it is 3.6. The reading of ammeter A1 will be, what is this current? Say this is I ampere and this will be I2 ampere and this will be I3 amperes. Or I1 I can write. I is divided as I1 and I2. This is 3.6 amperes, right? This is a parallel combination. This is a parallel connection. Short circuit. So the voltage across, say these are X and Y, these 2 points. So voltage across X and Y. So same as the voltage is available across this 12 is the same voltage available across 6 ohm. Potential, right? So if 3.6 ampere is flowing through this 12 means we can find the voltage Vxy. 3.6 into 12. So 3.6 into 12 will also be available across the 6 ohms. Vxy. Same Vxy, 3.6 into 12. Then I1 is equal to Vxy divided by 6. Between the two ends, what is the voltage available? Divided by its resistance value. So Vxy is 3.6 into 12 divided by 6. This is 7.2. Now the current I1 is found. 7.2. Using this 3.6 and 12, we are finding the voltage. Using the voltage, we are finding the current value. Then this current value is found. These two currents are added to find the value of total current. Total current is divided as 2. 7.2, 3.6, 10.8 is the answer. 10.8. If the voltmeter in the figure reads 12 voltage across the 90 ohm resistor, then the resistance of the voltmeter is, right? Usually ideal voltmeter is an open circuit, but the practical voltmeter will have some resistance, right? It has some resistance. Say RV. This voltmeter reads 12 voltage means voltage across this 90 ohm is 12 voltage. The voltmeter reads nothing but the voltage across this 90. So between these 2 points only it is connected, right? It has some resistance value. So the question is to find the resistance value of the voltmeter, right? If it is 12 means, let us find the current. What is the current through it? What is the current through it? Because to find the resistance value, we need V by I. V is available. 12 is the voltage. Parallel circuit. Voltmeter reads 12 voltage. So across it 12 voltage is available. Through the voltmeter, how much current IV, say this is IV, through the voltmeter, how much current is flowing. Then this 12 divided by IV will be the answer. So next step is to find the current through the voltmeter. Right. This is 12 voltage. This current we can easily find. This current, say this is total current I. This is divided as I1 and IV. I1 we can easily find 12 divided by 90. I1 is equal to 12 divided by 90. V by R. If this current is found, we can subtract this value from this total current to get this IV, then answer we will reach. Next step is to find the current through this 30 ohms. Right. If it is 12 voltage means, if you write Kirchhoff's voltage law, you can easily find what is the voltage across this 30 ohms. 18 minus 12 will be the answer, 6 voltage. The polarity markings are important, right? Assume a current is flowing, right? I, so this I will enter here, then leaves here. I enters the 30 ohms here, leaves here. Then I1 enters 90 ohms here, leaves here. Then it is coming back. Right, from any one corner, if you write Kirchhoff's voltage law, minus 18 plus this will be V30. This voltage across 30 ohms, I assume V30, voltage across 30 ohms, plus V30 plus 12 voltage. This voltage is known. So V30 is equal to 18 minus 12, 6 voltage. So V30 is equal to 6 voltage. Voltage across 30 ohm is found by writing Kirchhoff's voltage law around this loop. Easily you can write, it is 18, this is 12. So 6 will be resulted here. So 6 divided by 30 is I value. I value is voltage 6, resistance 30, the total current, right? From this total current, if you subtract this current, you will get IV, then answer we will get, right? IV is equal to, from the total current, I am subtracting I1. Total current is 6 by 30 minus 12 by 90. 18 by 12, 6 by 90. So 1 by 15. Current through voltmeter, IV. Current through voltmeter is now found, 1 by 15. Right. RV, resistance V is equal to VV by IV. Voltage across voltmeter, that is 12 voltage. This is 1 by 15. So 12 into 15 will be the answer. This is 120 plus this is 180. 150 plus 30, 180 ohms. Yes, option D. So voltmeter reads this voltage, 12 divided by 90 will be this current. If it is 12 amperes, this will be 6 amperes. We have checked by writing Kirchhoff's voltage law. Yes, this is 6 voltage. Then 6 divided by 30. V divided by R through this resistance. Locally, I am applying Ohm's law. V divided by R. I. From this I, we are subtracting this I to find this current through the voltmeter. To find RV, VV divided by IV. Select the correct option. The potential of point B is 7 volts. Potential of point B is 7 volts. The potential of point C is 4 volts. The potential of point C is minus 4 volts. The potential of point A is 2 voltage. A is earthed. That means this potential is 0. Potential of A is 0. That is the reference potential. So option D will be the wrong. It must be 0. The potential of only single point is given. We have studied potential of point VB. The next letter will be the reference. VB is equal to VB. If only one letter is in the suffix, the next letter will be the reference. Reference is A. 0 potential, right? VC, similarly, VC A. Potential at C with respect to the reference. Then VA. VA is equal to VAA. It is 2 voltage given. Actually, this is 0, right? So immediately we can remove option D. Right. Let us find the actual value of potential at C and B. 7 voltage, 1 ohms. Right. So let us 1 ohms. It is internal resistance. We have to take it also into account. Right. This is 7 voltage. This is 1 ohms. The battery itself has some resistance. Cells and EMF we will study. 7 voltage, 1 ohms. Then this is 2 ohms. This is point A, earthed. Then this is 4 ohms. 1 ohms. 2 ohms. 4 ohms. Point C, and this is point B. So only one path. It's a series circuit. 4 plus 2 plus 1, 7 ohms. 7 ohms is the equivalent resistance. All the three are in series. 7 voltage. V divided by R. 7 by 7 is equal to 1 ampere current. So the current through the battery is 1 ampere. So we need to find the voltage across B and C, right? So current through them must be found. That is why I am doing it. 1 ampere current, we have find it. 1 ampere current. So from the 7 voltage, 1 ampere current comes here. It enters 2 ohms, leaves 2 ohms. Enters 4 ohms, leaves 4 ohms. I into R, 1 ampere is the current. I into R, 2 voltage. I into R, 4 voltage, right? VB means VBA. This is VBA. VBA is equal to plus 2 volts. VB or VBA is equal to plus 2 voltage. So option A is wrong. Next, VAC, entering here, leaving here. VAC is equal to 4 voltage, or VCA is equal to minus 4 voltage, isn't it? VAC is equal to, this is VAC. If I connect a voltmeter between A and C, I will join the wire here, VAC plus 4 voltage. So VCA, if we joined it in the opposite way, it is minus 4 voltage. So VCA is VC. A is the reference value. So VC is equal to VCA. So this is VC. So VC is equal to minus 4. Option C is correct. So you must be very careful in such problems. It may look very simple, but wrongly writing either plus or minus will make you to lose 5 marks in NEET examination. In the given circuit, the current flowing through the resistance 20 ohms is 0.3 amperes. while the ammeter reads 0.8 amperes, what is the value of R? This is a short circuit. So voltage across the central branch is equal to voltage across 15, voltage across R. So this is the key point. The central branch, that is across 20 ohms, we can easily find the voltage I into R. I is available, R is available. So between these 2 points, 0.3 into 20. So 6 voltage. 0.3 into 20. Decimal point is 6 voltage. So between these two lines, 6 voltage is available. V by R, this current. V by R, 6 by 15, this current. So this is 0.4. So 0.4 ampere is leaving 15 ohms. 0.3 ampere is flowing through 20 ohms. This is, if it is 0.8, then application of Kirchhoff's current law at this junction will give you 0.1 ampere here. If it is 0.8, 0.4, 0.3, then it must be 0.1 ampere, right? V available, R available, current available, R easily fine. R is equal to, across R, what is the voltage? 6. Through R, what is the current? 60 ohms. Yes, option D. Next problem. 3 voltmeters having different resistance are joined as shown, and the readings are V1, V2 and V3. Right. When some potential difference is applied across AB, the incorrect option is, what is the wrong option? 3 voltmeters having different resistances. Let it be R1. Let me draw here. R1, R2, R3. The equivalent circuit. 3 different resistances. So R1 is not equal to R2, right? 3 different, similarly R3. They are not equal. The readings are V1, V2, V3. Voltage across R1 is V1, voltage across R2 is V2, voltage across R3 is V3. 3 different voltmeters are connected across them. The readings are V1, V2 and V3. Some potential difference is given between A and B. What is the wrong option, incorrect option? So sum of this voltage, because between these two terminals, the voltage is same. So it is divided as V1 and V2. So V1 plus V2 must be equal to V3. V3 is nothing but V. V1 plus V2 is equal to V3. This is correct. This is correct. But the question is to find the incorrect. V1 is equal to V2. V1 will not be equal to V2. Why? R1 and R2 are different values. I is same. Series circuit. Through R1 and R2 same current is flowing. I into R1 is V1. I into R2 is V2. Since R1 and R2 are different, V1 and V2 will not be correct. So this is incorrect. So this must be the answer. V1 is equal to V2. So other options, let us discuss. V1 is not equal to V2. If it is incorrect, this will be correct. If it is incorrect, this will be correct. It is equal to V2, it is not equal to. The currents in V1 and V3 are different. Yes, V1, R1 and R2, these two currents will be different. Let it be I1 and let it be I2. I1 and I2. Definitely they will be different, right? So this is also correct. this is correct statement, this is incorrect statement, this is correct statement, this is incorrect statement. The answer is option B. A, B and C are 3 voltmeters of resistance R ohms, 1.5 R and 3 R respectively. When some potential difference is available between X and Y, X and Y, Vxy. The voltmeter readings are VA, VB and VC respectively. Choose the correct option. VA, VB, VC all are equal. VA not equal to VB is equal to VC. VA is equal to VB is not equal to VC, and all are not equal. This is a parallel combination. B and C parallel. The current, whatever the value of current comes here, this will be divided. Different currents are flowing, so parallel combination. Parallel combination, voltage same. VB is equal to VC. VB is equal to VC. Yes, here it is available. This will not be a right. Similarly, this will not be a right. VB is equal to VC. So, option A or B is the correct answer. It must be A or B. Right. This is R ohms. VA, this voltage we have to check whether it is equal to this combination or not equal to this combination. This is R ohms. This is 1.5 R. This is 3 R. The R value makes the voltage values. Right. This is VA, R ohms. This is 1.5 R ohms and this is 3 R. These two terminals are X and Y. If we see the equivalent resistance value for this parallel combination, we will get the answer. 1.5 into 3, 1.5 into 3 R equivalent. 1.5 R into 3 R divided by 1.5 R plus 3 R. This is 4.5 R square divided by 4.5 R. So the equivalent value of this parallel combination is again R. This is also R. So between X and Y, the first R, the parallel combination is also giving R. So if you assume one current flowing through them, this voltage and this voltage will be same. This voltage is nothing but VB is equal to VC, parallel combination. B and C, VB is equal to C. This is VA. So VA is equal to VB is equal to VC is the answer, option A. If you simplify it, same R you are getting. This is also R, this is also R. This voltage is same, this voltage is same. Again, if you separate it, B and C, this voltage is equal to this voltage. So VA is equal to VB is equal to VC. The potential difference between 2 points A and B, that is VA minus VB, VAB between A and B. In the given circuit diagram, shown is, yes, for such problems already I have told you, between A and B the unknown potential it is asked, right. If you use the dummy battery concept, use dummy battery concept. If you use it, you will get the answer very easily, right? A, B is given, voltage between A and B, I will draw a dummy battery line. I will assume a battery is available. So A must be given the positive terminal. This is one important point. Yes. VAB. VAB is in question, right? So you can close this loop. You can close this loop. Along the blue line, I am going to write Kirchhoff's voltage law. How many components are there? Component number 1, component number 2, component number 3, component number 4. 4 components are here, right? So this voltage is unknown. This voltage must be known. Similarly, this voltage. These 3 voltages are known. We will get the answer easily, right? For them, we have to write Kirchhoff's voltage law here. 15 voltage. Say this is some current I. It comes here, here, here. What is it? This way it is circulating. 15 ohms. 5, 5, 5, right? So 15 ohms. 15 divided by 15 ohms. So this current is 1 ampere. Similarly, in this loop, from 15, 5 plus 5 plus 5, this is also 1 ampere. All the 3 are in series, right? A and B, it's an open circuit. A and B in an open circuit. Since it is an open circuit, we are making a closed loop through A and B by using the dummy battery. But in the original diagram, this is the 2 different loops are available. First loop carry 1 ampere, 5, 5, 5. Second loop carry 5, 5, 5, 1 ampere, right? The current entering terminal plus leaving terminal. Say this is I1. I1 enters here, leaves here. I1 enters here, leaves here. Then it goes to its battery. Similarly, I2, right? Enters, leaves, enters, leaves, enters, leaves. So this is 1 ampere. 1 into 5 will be 5 voltage. 1 ampere, 1 into 5 will be 5 voltage. For this also 1 ampere comes from top to bottom. Second loop. This 5 ohm is part of second loop. 5 voltage, right? So now all the components are having the voltage. This is unknown. Known voltage, known voltage, known voltage. Along the blue line, you walk through the path, right? We can easily write the Kirchhoff's voltage law. Let me start from this corner. That is from this point B, I am starting to write the Kirchhoff's voltage law. First, I enter this 5 ohms through this terminal plus 5 voltage. Then next 5 voltage, second component. What is the sign I am seeing? See the sign, write the value over. See the sign and write the value. I am seeing plus sign, I am writing the value. Seeing the first sign, writing the value. Then I see minus sign. First I see the minus sign. Minus 5. Then I go to A. Then along this line, coming, plus. Dummy battery plus VAB. Right hand side 0. Algebraic sum of potential is equal to 0. This plus 5, minus 5 are cancelled. VAB, this minus 5 is taken to this side. Minus 5 voltage is the answer. Option D. Yes. The ratio of the currents through 20 ohms resistor when the switch S is open and closed in the circuit as shown in figure. Right. Case 1, S is open. When S is open, from here the current comes, this is an open circuit, no current flows through the open circuit, S is open, right? So all the current will go through this 10 ohms only. If it is I1, I1 goes through this 10 ohms only. So 20 and 30, let me draw, it's equivalent circuit. This is the current path. 20 and 10. 5 voltage. So I1 is equal to V by R, 20 plus 30, plus 10, 30. When it is closed, this is the current path because it is a bypass. Now I have closed it. The switch is closed it. So for the current, then it goes through the bypass. Through the short circuit, no current flows through this 10 ohms. So the equivalent circuit, it is ineffective now. This 10 ohm is physically it is present in your circuit, but no current flows. No current flows means it doesn't have any effect in your circuit. So only 20 ohm is effective. So let us redraw this circuit as just 20 ohms. It is ineffective. The equivalent circuit, it will not come. This is 5 voltage. So I2 is equal to 5 divided by 20, V by R. So the ratio of the currents, I1 by I2 is the ratio. 5 by 30, I2 is 5 by 20. 5, 5, 0, 0 is equal to 2 by 3. 2:3 is the answer. Option D. Yeah. If you find a short circuit, you make all the currents to pass through the short circuit, bypass. Current passing through 3 ohm resistor is, what is the current passing through it? That is the question. 10 voltage is between A and C. This current, this voltage, it is 4 voltage. Two batteries are available. This is 10 voltage and this is 4 voltage. So to find the current voltage across 3 ohms, voltage across 3 ohms is equal to VBC. Just by seeing it, you can write the answer. This is 10 voltage. 4 voltage is detected here. So 6 voltage must be there. This voltage must be 6. This terminal is plus and this terminal is minus. So plus minus. Polarity not important, but this is the correct way of writing it. So 6 divided by 3 is the answer. Two amperes. Option C. So now voltage law will be satisfied. If 6 voltage, you can cross check it. If you have any doubt, you can cross check it. This is the loop. This is the loop. I start from here. I walk through this loop. First I see 10, so minus 10. Then I come here, plus 4. Then this VBC is not known, 0. Minus 10 plus 4 is minus 6. Plus VBC is equal to 0. VBC is equal to 6. This is what I wrote it already. VBC is 6. In the given network, find the value of I. I. Kirchhoff's current law. From this node, it is dividing. If 8 amperes goes this way, this will be 4 amperes. 4 amperes enters it. Sum of incoming will be outgoing. 8 amperes. Then 8 amperes, 2 is added, 10 amperes. Then 2 are incoming, I will be outgoing, 18 amperes. Option B. So easy question. The current flowing through 10 ohm resistor. What is the value of current flowing through this 10 ohm resistor? Right. 0. Option Z. Option D. Just by seeing it, you can write the answer. No current will flow through this 10 ohms. 0 amperes. How? This 18 voltage, from this 18 voltage, you assume one current I1. The tendency of electron is to reach its home. Its home means it's a battery. From where it has started, from the battery it has started I1. It wants to reach the negative terminal as quick as possible. That is the tendency of electrons. I1 leaving here, passes through 8 ohms, comes here, then returns to negative terminal. No current, no part of I1 will flow through this 10 ohms. Why? Suppose if you assume some portion of I1 is flowing through 10 ohms, then how it will return to 18 voltage? There is no way available for the portion of I1 which is divided from here to reach 18 voltage. No possibility. So this way, part of I1 will not go through 10 ohms. Similar is the case for 3 voltage and 11 voltage battery. All the currents or all the electrons will be circulating in this loop only. No part of, assume this is I2, no part of current will come to this side through 10 ohms. No part of I2 comes here, no part of I1 comes here. So 10 ohm, through 10 ohm resistance, I is equal to 0. Answer is 0. If you assume some part of some amount of electrons which is branched out from the total number of electrons, then how they will return back to their home, their own battery? No way. Yes, this is also one easy question. Figure those currents in a part of an electric circuit, then current I is 2 plus 2, then 4 amperes, 1 ampere is leaving, then this will be 3 amperes, then 1.3 is leaving, this will be 1.7 amperes. 1.7 amperes. Option A. In the given circuit, the potential at point B is 0. That means this is 0 potential, 0 voltage. The potential at points A and D will be what is VA and what is VD. So if only one letter is given, that means the second letter is the reference. VA is equal to VAB. Similarly, VD is equal to VDB. So we have to find VAB and VDB. 2 amperes, current entering terminal plus, leaving terminal minus, 2 into 2, 4 voltage. Then 2 amperes, current entering terminal plus, leaving terminal minus, 2 into 3, 6 voltage. Then this is already minus 3 voltage between C and D. First we have to find VAB. VAB, connect a dummy battery. Between A and B, 4 voltage. So VAB is equal to VA is equal to 4 voltage. Easily you can say VAB is 4 voltage. VA is equal to 4 voltage. This is correct. This is wrong. This is wrong. This is also correct. The answer must be either A or D. Right. Then we will find what is DB. VD, yes, this voltage. VDB. Right. Now I connect the dummy battery between D and B. VDB is asked. So D must be plus, B must be minus. This is VDB. For the second sub question, I am drawing another loop. I am connecting on a dummy battery this way. Let us start from here. Let me start from this corner. 6 voltage, 1, 2, 3, 3 components we have to write. 6 voltage, then minus 3, this is minus, shorter line, minus 3, plus VDB is equal to 0. This is 3 plus VDB is equal to 0. VDB is equal to minus 3 voltage. That is VD. VD is equal to VDB is equal to minus 3. Minus 3, option D. If you use the dummy battery concept, you will never make a mistake because the loop is closed. Then Kirchhoff's voltage law is easily applied. The potential difference VA minus VB, that is VAB. VAB is VA minus VB, that we know. So the question is VAB they are asking. In the circuit shown in figure is VAB. Connect a dummy battery. VAB, A is the first letter, so plus, minus. VAB. So 2 loops are now available. 2 ohms, VAB, 3 ohms. DAB, this is one loop. Another loop, ACBA. Loop ACBA. This is DABD. Either loop you can use. So I will use DA, the first loop. This loop I am going to use 2 amperes, right? Before connecting a dummy battery, the current will flow through this 2 ohms and 3 ohms only, right? First, let us have the original diagram. Find the voltages, then we will connect the dummy battery. That will be the right way of doing it. 2 amperes. This branch have 2 and 3. They are in series. It is current, it is divided. So this is 2 and 3 will carry same current. This 3 and 2 will carry another same current. So this is series, this is series. This is 2 plus 3, 5 ohms. In this upper path, 5 ohms. In this lower path also 5 ohms. 5 ohms, 5 ohms. They are equal resistances. The current will be divided equally. So this will be 1 ampere. This is also 1 ampere. 2 plus 3, 5. 3 plus 2, 5. 2 ampere will divide equally. So plus minus. 1 ampere enters here, leaves here. 1 ampere enters here, leaves here. This 1 ampere enters here, leaves here. And this 1 ampere enters here, leaves here. So I into R, 2 voltage. 1 ampere into 2 ohms. This 1 ampere into 3 ohms will give me 3 voltage. For this DABD, now I will connect a dummy battery. This is the time you have to connect a dummy battery. After finding out the voltages around all the components, you connect it. VAB. Now you complete the loop. DABD. This triangle like loop. It is closed. From D I am starting DABD through the dummy battery. Connecting a dummy battery, you must use the dummy battery to close your loop, right? Don't go to that side. So around the dummy battery, you must definitely close the loop. DA, then you are coming down. BD. This is 2 voltage. From D, I am seeing plus sign first, plus 2. First I am seeing plus 2. Then plus VAB. Then I am seeing minus. I am returning. From B, I am returning to D through this 3 ohms. First I am seeing minus sign. Minus 3. 1, 2, 3. 3 components have come up. Right. plus 2 minus 3. So VAB minus 1 is equal to 0. VAB is equal to 1. The answer is 1. Plus 1. Option C. Yes. In the circuit shown, the current I is this current. So Kirchhoff's current law we can use. This is the node. The currents meeting at this point is 0. All the incoming current is equal to outgoing current. Right. This is I. This is divided as I1 and I2. Two current, it is divided I1 and I2. Here 24 volts, this is 10 volt, this is 9 volts, all are joined here. Don't assume that this is zero potential. Wrong. Unless otherwise it is given, the potential at point B is given as 0, you should not assume it. If unknown potential is there, you must find the voltage. What is the value of voltage here? It may be 10 or 5 or any voltage. Because for the current to flow, it needs a potential difference. There is no need for the other end to have zero potential. If it is zero potential, 24 minus 0 is the current voltage value. If it is 10, 24 minus 10, right? So don't assume the common terminal as it's having zero potential, right? First point, right? We have to find the voltage at B. So this current I is divided as I1 plus I2. Kirchhoff's current law, incoming current is equal to outgoing current, I1 plus I2. From here it is starting, VA minus VB divided by 3, V divided by R. So VA minus VB divided by R value. So I1, it starts from here, VB minus 10. VB minus 10 divided by 2 plus VB minus 9 divided by 1 ohms. Yes. Incoming current V by R, V by R, V by R. So VA is 24. Straight away I can write it is 24. 24, yes. This is VB minus 10, this is VB minus 9, this is 24 minus VB. Yes. 24 minus VB by 3 is equal to, this is 2 VB minus 10 plus 2 VB minus 80. 2 VB plus VB, 3 VB minus 28 by 2. This is 24 minus VB by 3. Cross multiplying 48 minus 2 VB is equal to 48 minus 2 VB is equal to 9 VB minus 3 into 28, 84. So this will be 48 plus 84 is equal to 11 VB. The 2 VB goes there, 11 VB. This is 120, 132. 132 is equal to 11 VB. So 11 VB is 132. VB is equal to 132 by 11. 11, then 22, 2. Just 12. 12 voltage is the value available here. Now we have found after writing Kirchhoff's current law what is the value of the potential VB. This is what I told you already. Don't assume it is zero voltage. Right. So now the current I is asked. VA minus VB by its own resistance. So current I is equal to VA minus VB by the own resistance 3. VA is 24, VB is 12 by 3. So 24 by 12 is 12 by 3 is 4 ampere. The answer is 4. Yes, option C. Next problem. The given circuit VA minus VB is equal to 4 voltage. That is, VAB is 4 voltage. This voltage is 4. This is what given. Then the resistance X will be, what is the value of resistance X? So 4 is there. Around this loop, if it is 4 voltage, then this is 2 voltage, this must be a 2 voltage. So the Vx will be 2 between these 2 points, Vx. 2 plus 2 is equal to 4. So 2 is now available, voltage is available, then current through it must be found. Through X, how much current is flowing? Then I will use V divided by I. If I know this current, this Vx by I will be the X value. So for the current, I have to find the loop current. Only one loop is available. Don't assume through the dummy battery some current is flowing. This is for our convenience, we are drawing. This is an imaginary one, right? So the current is flowing through this loop only. This is the path of current, I amperes. I amperes. I. This is how only one loop, only one current it is flowing, right? So we have to write the Kirchhoff's voltage law around this loop using the I value, then I must be found. Anywhere you can start. From here, from A, let us start. So current entering terminal plus, leaving terminal minus. Entering terminal minus, so this is entering terminal, this is leaving terminal. I am seeing first 2 voltage. From A, from this point, I am starting to write the Kirchhoff's voltage law, right? Plus 2, then this is X ohms, I into X ohms, or the voltage is now immediately available. 2 voltage we can easily write. This is 2 voltage. Vx is equal to 2 voltage. Yes. Plus 2, then minus 5, plus 10i. Plus 10i is equal to 0. So this is minus 5, minus 1, plus 4, minus 5, plus 10i is equal to 0. So 10i is equal to 1, I is equal to 1 by 10, 0.1 amperes. 0.1 ampere is the current that is flowing through. I is equal to 0.1 amperes. So through the unknown X value, the 0.1 ampere is flowing. Across unknown X value, 2 voltage is available. Ohm's law we can apply. X, that is resistance value. V by Vx by Ix. Vx is 2 voltage. Ix is nothing but the current. The same current, only one current is available, 0.1 amperes. So 2 by 0.1, 20. X value is 20 ohms. 20 ohm is the answer, option D. In the given circuit, the potential difference across R ohms. This voltage is how much? One battery, one series resistance. Another battery, another series resistance. If such combinations are available, one shortcut method is available. We can use that shortcut method, or otherwise you can write Kirchhoff's voltage law around this loop and this loop. Around this loop, loop number 1, Kirchhoff's voltage law, assume different currents. mark the polarities, entering terminal plus, leaving terminal minus, you can complete it. This is loop number 2. This is loop number 2. This is another way of writing. Right? So this shortcut method, in cells EMF also we have used it. 10 voltage, 2 ohms. Similarly, 5 voltage, 1 ohms. They are in parallel. Two batteries along with their internal resistance. They are said to be their internal resistance. Inside the battery, some resistance are available. We can assume they are internal resistance of the batteries, respective batteries. The equivalent value, this is V equivalent. How parallel resistors are combined? Similarly, how the batteries with some parallel internal resistance are combined. This is R equivalent. I can make a single battery with single resistance V equal and V R equal. Let it be A, B. Between terminals A and B, I will easily find. There is one formula available. Please remember, this is important point. Please remember, proof is available. You can easily prove it. By writing Kirchhoff's current law, you can easily prove it. But remember the formula. V equivalent is equal to sigma V by R divided by sigma 1 by R. R and R will get cancelled. V will be the left hand side V, right hand side V. Right? Sigma, sum of voltage divided by resistance. V by R plus V by R, or V1 by R1 divided by V2 by R2. That is the meaning. Sum of V by R divided by sum of 1 by R. Then 1 by R equivalent is equal to, the denominator is 1 by R equivalent. Sigma 1 by R. That is 1 by R1 plus 1 by R2. This is 1 by R equivalent. Yes, this is one formula. This is main formula, V equivalent. Sigma V by R, that is sigma I. V by R is nothing but current. Sigma I divided by sigma 1 by R. The R dimension wise, both side voltage will have V equivalent. V is in terms of some volts unit. R and R, if you cancel it, you will get the right hand side also R. This way you can remember it. Right. So V1 by R1, I am finding V equivalent. What is V equivalent? V1 by R1, 10 by 2. Sum plus 5 by 1 divided by 1 by R1, 1 by 2 plus 1 by 1. So this is 5 plus 5 divided by 1 by 2 plus 1. So this is 1 plus 2 by 2. So this is 10. This is 3 by 2 is equal to 2 by 3. 20 by 3 is the voltage, equivalent voltage. If you simplify it, 20 by 3. Then 1 by R equivalent. 1 by R, already we have found it. This is 3 by 2. Then R equivalent will be 2 by 3, reciprocal. So this is V equivalent and R equivalent. Now they are found. Between the 2 points, V equivalent, it is 20 by 3. R equivalent 2 by 3. Between A and B, these are A and B. This portion is simplified. Between A and B, 10 ohm is connected. Yes. Potential difference across these 10 ohms. So we need to find the voltage, current. This current is found, then I into 10 ohms will be the voltage, right? So this is voltage available, 2 by 3 plus 10 will be these two are in series, right? R equivalent and this 10 ohms. These two are in series. Easily we can write what is the current value. I is equal to 20 by 3 V divided by R. R is 10 plus 2 by 3 is equal to 20 by 3 divided by 32 by 3. So 3 and 3 will be cancelled out. So this is 20 by 32. 5 by 8. 5 fours are 20, 8 fours are 32. 5 by 8 is the current value. This current is 5 by 8 amperes, right? So V equivalent, R equivalent I am finding. I am making a single voltage with single resistance. So this formula, you can remember it. Very useful formula. V equivalent, R equivalent. The proof, you need not to find the proof. Just you remember the formula. The topic cells EMF, this type of problems will be again coming for your practice. You can use them, right? Right now, I is equal to 5 by 8 amperes. Right. The voltage across 10 is equal to 5 by 8 I into R. V across this voltage. Say this is V1. V1 is equal to 5 by 8 I value into R. So this 4-2, this is 5-2. 25 by 4, this will be 6.25. 6.25 is the answer, yes, option B. Option B. So in this exercise, you have to remember this equivalent way of finding two batteries with their internal resistance. If one of the internal resistance will be there, then it will be a bit difficult for you. Don't use this method. Battery in series with one resistance, another battery in series with one series resistance. They must be come in parallel. Then you can adopt this formula. Yes. 5 conductors are 1, 2, 3, 4, 5. 5 conductors are meeting at point X. As shown in figure, what is the value of current in the fifth conductor? 1, 2, 3, 4. What is the value of current? 3 ampere away from X. 1 ampere away from X. 4 ampere away from X and 1 ampere towards X. What is the right option? 5 amperes incoming, 4 amperes incoming, 5 amperes outgoing, 3 amperes outgoing, right? 5 plus 4 incoming is equal to 5 plus 3 plus Ix, unknown value. So this is 9, this will be 8 plus Ix. So this is 1 ampere. The 5 ampere is, let us assume all the 5 amperes are written in this way. Just by seeing the diagram, you can assume 4 amperes. Out of this 4 ampere, 3 ampere is going away. So this is 1 ampere. 1 ampere is the result. 1 ampere is going away from X. This is the right option. 1 ampere. 1 ampere away from X. Yes. The value of current I in the network shown below is 5 amperes incoming, 5 amperes incoming, 3 amperes incoming, 5 ampere outgoing, right? 2 ways you can find the result, right? It is a short circuit. It is a short circuit, short circuit, short circuit, short circuit, short circuit. So the short circuit made as a node, 15 amperes 5 amperes (3 amperes), then this is I amperes, 23. These are incoming, so this must be 23 amperes. So this is a short circuit. You can make it as a node. Yes, you can make it as a node. 23, option C. In the circuit shown in figure, if the potential at point A is taken to be 0, this is 0 potential. That means reference potential. The potential at point B is VB is equal to what? So only one letter, writing one letter means the another letter is the reference. 0 potential it is given, so VBA is asked. VBA is asked. Potential between B and A is asked. So let us use the dummy battery concept. Easily we can find the result. Between B and A, let us connect one dummy battery. Using the dummy battery, we will close the loop. Right. Before it, we have to find the voltages. 1 ampere, which is coming from 1 volts. This is 2 amperes. So that means this is 2 amperes. 1 ampere up to this point it is coming. So this must be 1 ampere. These two are added and 2 ampere is coming. 2 ampere. Up to this point 2 amperes. Then 1 ampere it is going downwards. So this must be 1 ampere. Yes, it is true. 2 minus 1, this will be 1 ampere. The same 1 ampere is flowing through this branch. Right. R value is not given, ohmic value is not given. So voltage we can't find. This is 1 ampere. This 1 ampere enters the upper terminal or upper end, leaves the bottom end. Yes. 1 into 2, I into R, 2 voltage. Yes. R2, ohmic value, not numerical value is given. So voltage cannot be found, voltage cannot be found, voltage cannot be found. So this voltage available, this voltage available, this voltage available. Now let me draw the dummy battery. Between A and B, VBA. So give positive terminal to B. Negative terminal to A. So this is how I am going to close the loop. Drawing dummy battery is to close the loop. The green line is the path or loop. How many components are there? 1, then 2, then 3, then 4 components. 4 components I am seeing in the path what I have chosen. Yes. Wherever you can start your walking. I start to walk from terminal A. I go this side. Either way you can go to. Either way you can walk. From A I am seeing -1 first. First component. Then I am seeing -2 voltage. Then I am seeing +2 voltage. Then I am coming to this battery. First I am seeing plus VBA. All the 4 components. Yes. 2 and 2 are cancelled. VBA is equal to 1 voltage. -1 will go to that side. Over. Yes, +1. plus 1. Option A. Just connect a dummy battery between the 2 points where the question is asked. Using the dummy battery, close the loop with the available voltage values. I can't connect this way because this voltage is not available, this voltage is not available. Otherwise, we can close this loop this way, VBA. These two voltages are not available, we can't find because R1 and R2 they are given, no ohms value is available. I hope you have understood all the concept and the solution well, right? I have used the dummy battery concept extensively here, right? It is an easy way of doing one, and unique way of doing one. Easily we can find the answer. Polarity marking is very important, right? If you use this technique, you won't make any mistake in the polarity markings and getting the right answer, right? All the best.